I guess I should admit that I really love covalent bonding, and it's just such a fascinating topic. It also is a very beautiful thing to study. Here's a few different representations. Here's a bond being formed. Here's a simple molecule of rubbing alcohol, and here's a more complicated molecule, a biomolecule, something so large that if you tried to take it as a pill, your body would simply digest it. Now, I did go to the trouble of just showing these on another screen, so bear with me here. And there's the rubbing alcohol molecule. And a nice thing is that there's now very cheap freeware programs which allow you to manipulate these. Look at this, how you can play around with this thing and take a look at it. You know, you can check it from this angle, you can check it from this angle, you can just let it spin and see what it looks like. So it's really good for understanding the stereochemistry, the three-dimensional nature of these molecules. The larger molecule should be right here. Oh, and there it is. This is a transcription factor, a big biomolecule, and it looks like they showed how it's docking into DNA. And I can grab this one too. It's a little bit lower res. It doesn't do it as smoothly because it's so big. But somewhere in there, this molecule, you can try to poke around to try to see that key spot. Maybe somewhere around there it's interacting, or maybe it's these strings here. Look at that, how they seem to be interacting with the DNA. You can try to find that angle that shows it. Wow, it looks like it's forming like a knot practically in there. Anyhow, this is the world of covalent bonding, the world of organic chemistry. And let's go ahead and take a look at it. We'll be looking at what a covalent bond is, and let's just go ahead and reveal it's a bond between two nonmetals. Everything's to the right of the staircase. So all these things here, there's no metals present. You know, these big things might have one and two hiding in there, you know, in a metalloenzyme, for example, but largely no metals present. That's a covalent bond. It's a bond based on sharing electrons, which is nice. This is Screencast 7.8. How does electron sharing work? Let's go ahead and take a look at that. We're going to merge in with Screencast 7.9. And this little mechanism here is supposed to give you an idea of how this takes place. Okay. We can draw electron dot structures to represent the outer shell, and I've done that for fluorine. And so let's try it for neon. How many valence electrons? 8. So it's got a full outer shell, and that's represented like this. This means it doesn't need to do anything. It's fully stable. Try it for hydrogen, oxygen, nitrogen, and carbon. Pause this video and go ahead and do it. You should find that hydrogen has 1 valence electron, oxygen has 6, nitrogen has 5, carbon has 4. These are a little shifted. But when you spread them out in accordance with Hund's rule, and we've done this before, you'll find that oxygen form 2 bonds, nitrogen 3, and carbon 4. Don't forget to spread them out. Okay, so the number of bonds, 1, 2, 3, 4. Honk if you love chemistry. Here's the key, lone pairs, none for hydrogen. Here's the 2 lone pairs for oxygen. They don't get involved in bonding, but they take up space. And there's 1 lone pair for nitrogen, none for carbon. Fine. Okay, this little visual here is the real big thing that I want to show you. Let me back it up. Here's how sharing electrons works. This has 7, it wants 8. This has 7, it wants 8. You'd think if you transfer it, it doesn't work, right? This becomes positive. This becomes negative. This one's happy, F minus. It's okay, it's got 8 electrons. This guy, oh my god, it's totally unstable. It lost an electron. No way does it have a noble gas configuration. So, it's solved by sharing. Can you see how this has 8 electrons each? This should help. See those 2 circles? By merging, you've got 8 electrons each. This is the essence of covalent bonding. Draw this and make sure you understand it. If you do, you should be able to answer me this. What's up here? What's going on with this intersection? Answer? That's the bond. 2 electrons form that bond. Those are the electrons that are shared. That's what a bond is. In this case, a covalent bond. 2 shared electrons. It's sometimes drawn this way, where the line represents the 2 electrons, and sometimes they throw all those lone pairs around. But it's the bond that's the key part of it. This is Screencast 7.9 and 7.8.